All right, welcome everybody. So far you've had a chance to look over, hopefully, some notes and some information on molarity. We've talked about solutions so far, parts of a solution. We're going to review that here momentarily. You looked at how to calculate molarity. You looked at the equation to solve for molarity. You looked at how to calculate molarity when you're given mass. When you're missing some information and you have to take an additional step to find what is ultimately unknown. So we're going to review some of that stuff. We're going to practice some of our calculations. And then by the end of this video, I'm going to introduce you into what we call dilutions. We're going to talk about what a dilution is, and we're going to look at how to calculate those as well, so that later on in this week you can perform these calculations on your own. All right, well, let's go ahead and get started with a little bit of a review. So number one here says solutions are examples of blank mixtures. So what kind of mixtures are solutions, and why, basically, is what this question is asking you. So solution is an example of a homogeneous mixture, and it's homogeneous because when you look at it, it all looks the same. It all looks like the same substance. Therefore, you cannot distinguish the different ingredients that are in this solution. So this is answer choice A. Looking at number two, which of the following is not correct about a solute? And your answer choice says it dissolves, it's the lesser amount, or it's usually in water. Well, we looked based off of the notes before. We know that a solute is typically the substance that dissolves in the water, if water is part of your solution. It's normally in the lesser amount of the two. Therefore, the one that is not correct here is C. The solute is not usually water. Typically, the solute is what dissolves inside or into the water. Number three, in a saltwater solution, blank is a solute and blank is a solvent. So in a saltwater solution, you need to determine what is a solute, what is a solvent. So the solute is typically in the lesser amount. The solvent is typically in the greater amount. So if I have saltwater solution, I've got salt and water, which is usually in the lesser amount, and that would be the salt. So the salt is considered the solute, and the larger amount, the water, is my solvent. So the best answer here would be A. Number four, most liquid or aqueous solutions will use what as a solvent? And a little hint here is because it is called the blank, so it's got a nickname. And I'll go ahead and write that on here for you. Most liquid solutions use water as a solvent, which is why water is known as the universal solvent, because a lot of things can dissolve in water. The next one, concentration measures what in a solution? So the concentration is measuring the amount that is dissolved in the substance. So therefore it's measuring the solute, the amount of solute in my solution. Number six, in chemistry, when we measure the concentration of a solution, what are we measuring? So the calculations that we've been looking at, we're calculating the concentration of the solution, which is known as molarity. So how do you pronounce 1m? Well, we know m represents molarity, but I wouldn't pronounce this 1 molarity. I would simply pronounce this as 1 molar. A 1 molar solution. All right. So let's see here. Moving on. In number 8 and 9, we want to determine certain values like moles, volume, or the molarity of a solution using our molarity formula. So I'll write up here the molarity formula in case you forgot it. The molarity formula is M equals molarity equals the amount of moles divided by the volume, which is always in liters. So molarity is moles divided by liters. Now whenever we're calculating molarity, our volume must always be in liters, and I'll show you how to change to liters here in a minute. So number 8 says, what is the concentration of a solution that has 0.75 moles of sodium chloride and is dissolved in 2.5 liters of water? So let's take a look at what we've got here. It tells me the amount of moles of sodium chloride, so it's giving me moles, and it's telling me it's dissolved in 2.5 liters, so it's telling me the volume in liters, so I'll write this as a capital L. So my formula is molarity equals moles divided by liters. So I'm going to plug in what I know. I know the amount of moles is 0.75, and the volume is 2.5. So what are you solving for? Well, if it's asking you what is the concentration, then that means it's asking you for molarity, which means molarity is unknown. So 0.75 divided by 2.5 liters gives you 0.3. So this solution is a 0.3 molar solution. Number 9, how many moles of sodium hydroxide is in 0.65 liters of a 6 molar solution? So let's look at what we've got. We've got 0.65 liters, that's measuring my volume. 6M, M stands for molarity. This is a 6 molar solution, so my concentration is 6 molar, which is M, and I want to know how many moles is that. So I'm solving for moles. So your formula, M equals moles divided by liters. So this time I'm given the molarity, which is 6. The moles is unknown, and volume is 0.65 liters. Alright, so I want to solve for the amount of moles, so I'm going to cross multiply here. 6 times 0.65 is going to give me the number of moles, and 6 times 0.65 should give me 3.9. So there should be 3.9 moles of sodium hydroxide in the solution. Okay, so let's take another look at molarity using mass in grams. So we just finished an entire unit where you were asked to convert things like moles to grams or grams to moles. So in case you are still struggling with that concept, we'll kind of review this here. So when molarity is required, but we are given mass, we need to figure out what do I do with mass, because mass is not in your molarity equation. Well, you need to convert it to moles, just like we practiced in our last unit using your T-charts and so forth. So question 10 says, find the molarity of a solution in which 58 grams of sodium chloride are dissolved in 1.5 liter of water. And then it gives you a little hint down here below. It says when given grams, change the grams to moles, and then use the molarity formula. Alright, so let's identify what's given to us. I'm given 58.0 grams of sodium chloride and 1.5 liter of water. So liters is a unit of volume, so this is L in my molarity equation. And grams, that's measuring mass in grams. Unfortunately, there's no G in this equation. So when given grams, I need to convert grams to moles first and then plug moles into this equation to find molarity. So what I'm trying to solve for is molarity, but in order to get to molarity, I've got to solve for moles first. So I'm going to set up, I'm going to take what's given here, my 58 grams of sodium chloride. So 58 grams of NaCl. Set up my T-chart, bring down my units, and I'm converting grams of sodium chloride to moles of sodium chloride. And this is a molar mass conversion, therefore 1 is always the value for moles. And now I need to refer to my periodic table to figure out the mass of sodium chloride. So when I look at the periodic table, and hopefully you have a periodic table nearby, on the periodic table, sodium's got a mass of 22.990, and chlorine has a mass of 35.453. So when I take 22.990, and I'll write that down here below, 22.990 plus 35.453, then I get a mass of 58.443. And now I do my calculation. So when I take 58 grams of sodium chloride times 1, divide it by 58.443, you should get an answer of 0.99, we'll carry one more decimal place, 2 moles of sodium chloride. Now, that's great. That's not my final answer. So what I've noticed on the previous assignment is that we figured, well, I'll just solve for one thing and call it a day. Well, yes, this is important, but it's not the final step. So you have moles here, but you're trying to find molarity. So now you need to take this value and plug it into this equation to find molarity. So step 1 was just completed. So let's do step 2. So step 2 is using our molarity equation. Okay, and for moles, I'm going to plug in what I just found, 0.992. And then liters was given to me up in the problem as 1.50. So now I do the math. 0.992 divided by 1.5 gives me 0.66 molar solution. 0.66 m. All right, let's take a look at another one here. It says, what mass of calcium bromide is needed to make a 0.5 liter solution of 0.554 molar? So it's telling me the concentration. This is m. And I want to know mass. So it's asking me to solve for grams of calcium bromide. So that gives you a hint. Here it says, when asked for mass, first find the moles using molarity, and then change moles to grams. Okay? And the reason I want to do that is because my equation is m equals moles over volume. And you'll notice that there's no grams in this equation, therefore it's not going to do me any good. Alright, so first step, find the moles using molarity. Okay, so I'm going to use my equation, and I'm going to plug in what I know. So molarity is 0.554 equals moles, I don't know yet, and liters, volume, is 0.500 liters. Okay, so what we're going to do is we're going to cross multiply, and we're going to solve for the number of moles. So 0.554 times 0.5 gives me 0.227. I'm sorry, 0.277. And this is moles of calcium bromide. So now I want to convert that to grams. So what I'm going to do is I'm going to set up my T-chart. So I'm going to bring down what I know. Moles of, my units, moles of calcium bromide. And I want to convert moles of calcium bromide to grams of calcium bromide. So this is again molar mass equation or conversion. So 1 is always my value for moles. And now I need to figure out how many grams of calcium bromide are in 1 mole. Alright, so on your periodic table, you should find calcium and bromine. So calcium has a mass of 40.078. And bromine has a mass of 79.904, But you'll notice my equation shows, well, my formula shows 2 bromine atoms. So 2 bromine atoms has a mass of 159.808. And when I add those two together, I should get a molar mass of 199.886. So now I'll do the math. And I'll take 0.277 and multiply it by the mass in grams, which is 199.886. And when I do that, I get a mass of 55.37 if we round up. So 55.37 grams of calcium bromide. Okay, so let's continue moving on. Couple reminders here that if we're using the molarity formula, we want to make sure our volume is in liters, which is what we've been practicing. You've seen the examples. They're all been in liters. Couple things that you should know, if you don't already know, is that if you're given a volume in milliliters, because we can measure volume in milliliters as well, we need to change it to liters. So how many milliliters are in 1 milliliter? Or, I'm sorry, there are 1,000 milliliters in 1 liter, excuse me. So my factor is 1,000. So in order to convert from milliliters to liters, I have to divide my value in milliliters by 1,000. And what you're basically doing is you're moving the decimal 3 times or 3 places to the left. So let's take a look at it. Here I've got 256 milliliters. I want to figure out how many liters that is. So you can take 256 and divide it by 1,000 and you'll get an answer. Or easiest way is if your decimal is right here at the end of 256, like 256.0, then I would move my decimal 3 places to the left. So there's 1, there's 2, here's 3 places, which will give me 0.256 liters. So looking at the next one, I've got 3.5 milliliters. So you could take 3.5 and divide it by 1,000 and you'll get an answer, or you can simply move the decimal 3 places to the left. So there's 1. Let's try that again. There's 1, 2, 3. So my decimal will be right here, which means I plug in 2 zeros. And this value becomes 0.0035 liters. All right, and looking at the last one here, I've got 48 milliliters. So either 48 divided by 1,000 will give you your answer, or you move your decimal 3 places to the left. 1, 2, 3. My decimal goes here, which gives me a value of 0.048 liters. Alright, so let's take a look at the next problem here. It says calculate the molarity of a solution that has 1.25 moles of solute and 325 milliliters. So you want to calculate the molarity, which is M. It gives you 1.25 moles and it's in 325 milliliters. So milliliters is a unit of volume. We just talked about how to convert milliliters to liters. So we're going to convert 325 to milliliters to liters by moving the decimal. So 325 divided by 1,000 gives me 0.325 liters. All right, so my formula is molarity equals moles divided by liters. Molarity is unknown. I've got 1.25 moles and 0.325 liters. So 1.25 divided by 0.325 gives me a molarity of 3.85 as my answer. All right, so we're going to move on here. Now we're going to look at the differences between molarity and dilution. So molarity expresses the amount of solute per volume. So it tells you the amount of a substance that's dissolved in a solution. Okay, and it's volume per liter. A dilution involves changing the amount of the solvent. And when I change the amount of the solvent, then the concentration changes as well. So we go ahead and fill in this blank here, solvent. All right, so here's an example. I've got a concentrated solution here. So if you notice, I've got a volume of 200 milliliters, which is 0.2 liters. And inside of this water, I've got 7 molecules. I can count them. 1, 2, 3, 4, 5, 6, 7. So I've got 7 molecules in 200 milliliters of water. So this is a concentrated solution because I've got a lot of solute and very little solvent. Now, if I look at a dilute solution, what a dilute solution is I've got those same 7 molecules. 1, 2, 3, 4, 5, 6, 7. But what's changed is now the volume of water is so much greater. Now I've got 400 milliliters of water. So yes, it's the same amount of solute, but the solvent is significantly greater. So what I've done is I've diluted that solution. Okay. An example: if I'm making tea, and I put tea bags inside some boiling water, and I've got just a little bit of boiling water. When I pour that boiling water that's got the tea bags in them after a few minutes into a container, the tea is going to appear very dark. It's going to be very strong because I've got a lot of tea in very little water. So how do I dilute it a little bit and make it drinkable, make it to where it's not as strong? So I would just add water to it, and I would add water to it. The tea would get lighter because it would become more dilute, less concentrated. So let's take a look. It says the original solution was diluted by having water added to it. So did the volume change? Well, yeah, the volume was originally 200 milliliters and now it's 400 milliliters. So the volume increased by 200 milliliters. So we just say it went up by 200 milliliters. Did the moles of the solute change? Okay, did the amount of molecules change? And the answer is no, because there were 7 here and there are still 7 here. Did the molarity change? Well, the molarity, otherwise known as the concentration, did change because I had 7 molecules in 200 milliliters, and here I had 7 molecules in 400 milliliters. Therefore, it did change. So in other words, if I want to calculate the molarity of this solution, I would take 7 and divide it by 0.2. And 7 divided by 0.2 is 35. If I did the same thing over here and took 7 and divided by the new volume, which is 0.4 liters, then I would get 17.5. So it was originally a concentration of 35, and now it's a concentration of 17.5. So the concentration was cut in half. So when I doubled the volume, the concentration decreased by half. Okay, so how do we determine how dilute or how concentrated a solution is? Well, we're going to use the formula that's presented here, and I'll explain that here in 1 second. I've got V1 M1 equals V2 M2. So what's different about this type of problem, which makes it different from calculating molarity, is that in a molarity calculation, your volume has to be in liters. In a dilution calculation, your volume can be in milliliters or liters as long as it's the same for both volumes. So what we're doing is we're comparing a volume and a concentration of a solution at the beginning compared to a new volume of a solution after something changes. Either the volume changes or the concentration is going to change as a result. The volume and the molarity are going to change between those two solutions. So when you're reading a dilution equation or a problem, the dilution equations they're going to give you two volumes. They're either going to give you two volumes or they're going to give you two molarities in the problem. And what might kind of tip it off is that the word "of" usually connects the values of the same solution. And I'll tell you what I'm talking about here in a moment. So our first problem says, what is the concentration of a solution made by diluting 2.5 liters of 11.7 molar HCl to 4.5 liters? Well, here it says I'm diluting 2.5 liters. Here's that word "of" 11.7 molar HCl. So this is telling you that this volume corresponds to this molarity. So this amount in liters corresponds to this amount concentration of HCl. So these are both in the same solution. So I'm going to mark them V1 because that's my initial or starting volume, and this is M1, that's my starting molarity. And the solution is being diluted from 2.5 liters to 4.5 liters. So it started off as 2.5 and now it's 4.5. So I can tell it increased. So this is my new or my second volume. So what do you think you need to solve for? Well, we have V1 and M1 and V2. So the only thing that's missing is M2. So the concentration I'm trying to find is M2. So my equation is V1 times M1, the volume and molarity of the original solution, equals V2 times M2, which is the volume and molarity of the new solution. So we're going to start by plugging in all the values that we know. So for V1, I know I have 2.5 liters. The molarity of the first solution is 11.7 equals the new volume is 4.5 liters, and the new molarity or the new concentration of that solution is unknown. Alright, so the first thing that I like to do is combine like terms. So I'm going to combine the like terms over here, 2.5 times 11.7, and that gives me 29.25. And it's still equal to 4.5 times M2. So I want to get M2 by itself, but it's being multiplied by 4.5. So I need to move that 4.5 to the other side by dividing it. So 4.5's on the right cancel, and I get 29.25 divided by 4.5, and that gives me a value of 6.5. which is the concentration of the new solution. Alright, let's take a look at the next example. It says a solution was prepared by diluting 5,500 milliliters to 7,500 milliliters of 0.477 molar KOH, potassium hydroxide. What was the concentration of the original solution? Okay, so let's look at what we've got here. It says it's diluting 5,500 milliliters. Milliliters is a volume. 7,500 milliliters. Milliliters is also a volume. 0.477 m. M measures molarity. Okay, so the first thing you need to do is identify what's a volume and what's a concentration. Okay, here's that word of. It says 7,500 milliliters of 0.477 molar KOH. So it's telling me that this volume and this molarity are of the same solution. And another context clue says that it's being diluted. It's diluting this amount to this amount. So this is the original amount. This is the new amount. So I'm going to label this V2, M2. Now, it really doesn't matter for the calculation's sake as long as you've got them paired up properly. So I'm going to name this V1, which means I need to figure out the concentration of the original solution, which is normally M1. So, same equation. V1, M1 equals V2, M2. So I'm going to plug in what I know. I know V1 is 5,500, M1 is unknown, equals V2, which is 7,500, times M2, which is 0.477. So like we did in the previous problem, I'm going to combine like terms. So 7,500 times 0.477 on the right side gives me 3,577.5. And on the left, I still have 5,500 times M1. So I want to bring leave M1 by itself. So I'm going to divide both sides by 5,500. So those cancel on the left, which gives me M1 by itself. So I've got 3,577.5 divided by 5,500, which gives me a molarity of 0.65. My concentration of the original solution was 0.65. All right, moving on, we're down to our last two here. It says, what volume of 15.6 molar NH4OH, ammonium hydroxide, is needed to make 0.5 liters of 9.5 molar solution? All right, so step one, identify what's a concentration, what's a volume. So 15.6 m, that is a concentration. 0.5 L, that's a volume. 9.5 m, that's a concentration. Okay, it even says what volume. So I'm solving for a V. Now let's figure out what's V1, what's M1, and so forth. Well, here it says it's needed to make 0.5 liters of 9.5 molar. So there's that word of, which tells me that those two are part of the same solution. So they're going to have the same number subscript attached to them. So we'll go ahead and label these V2, M2, and we'll make this V1, M1 as my starting solution. Okay, there's that word of again. So my equation is V1, M1 equals V2, M2, where V1 is unknown, M1 is 15.6, equals V2 is 0.500 liters, and M2 is 9.50 molar solution. So I'm going to combine like terms. So 0.5 times 9.5 on the right side gives me 4.75, and on the left I still have the same 15.6 times V1. Now I'm going to divide both sides by V1. I'm sorry, by 15.6, allowing those to cancel out. So the volume of that original solution is 4.75 divided by 15.6, which gives me 0.30 liters, or 0.304 if you want to carry out another decimal place. All right, my last one here. How many liters, so it's already asking for liters, so I know this is a volume, of 0.085 molar, there's my concentration. There's that word of, so we'll just go ahead and label those because we're there. Sulfuric acid can be prepared from 25.0 milliliters of 35.9 molar solution. So I've got my volume and molarity of my second solution. Remember that word of ties them together. Now, one thing that I notice is that it's asking how many liters, my volume, my original volume, but when I look at this volume, it's measured in milliliters. So they both measure volume, but when you're doing these dilution calculations, your units have to be the same. Now they can be either both in liters or both in milliliters. I'll let you make that decision, but I'm going to make my milliliters into liters over here to the right. So 25 divided by 1,000 gives me 0.025 liters. So that's the volume that I'm going to use. Okay, so my formula V1M1 equals V2M2. So V1 is unknown. M1 is 0.085 equals V2 is 25.0 and M2 is 35.9. Excuse me, I take that back. My volume is not 25, it is 0.025. There we go. Times 35.9. All right, so we're going to start by combining like terms. On the right side, I've got 0.025 times 35.9. That gives me 0.898 if we round up. And on the right, I've still got V1 times 0.085. So I want to divide 0.085 to the other side. These cancel out, and I'm left with V1 all by itself. So 0.898 divided by 0.085 gives me 10.56, and we converted our volume to liters. Therefore, 10.56 or 10.6 if you round to the nearest tenth is your answer. So hopefully these calculations help. When you're working on the Google form, I suggest that you fall back and maybe rewatch these to assist you with the Google form. If you have any questions, please feel free to join us on Thursdays for some virtual tutoring. We can certainly address any of these issues or concerns that you might have.